Good morning, everyone, and welcome to our ongoing series in Central Region of Science Sharing webinars. And today we have a repeat performance by Lance Rothfusz, who's the Deputy Chief of the Warning R&D Division and currently Acting Deputy Director of NSSL. And he'll be talking about what he calls Facets, a new watch warning paradigm and framework for progress. So without further ado, Lance, it's all yours.
All right. Thank you, John, and welcome to all who are joining today. And if for those of you who have sat through my presentation in the past, I appreciate you coming back and get a second dose here. It occurred to me as we were talking and sitting here listening this is my representation of the polar vortex right there. So I thought I had actually throw that in there for some currency of what's in the media these days. Anyway, I'm going to move on. If you come away from this presentation with nothing else than these two concepts, then I will have succeeded. And these two concepts are facets is, first of all, a new watch warning paradigm, and I should probably change the word new to proposed watch warning paradigm, and you'll see what I mean as I get deeper into the presentation. So the first thing that Facets is that new paradigm, a new idea for how we do watches and warnings in the future. And then the second thing is that it is a framework for progress. Anytime you start changing things and working on a project, you end up having a project plan. And what we discovered as we were sort of divining this, the whole idea of Facets sort of worked its way into a framework for how we can move forward. Again, that'll make more sense as we go through. So again, at the very end, if you walk out of here with nothing else, you at least know what Facets is. It's a kind of new paradigm and also sort of a framework for moving forward on things. So I start my presentation with this little nugget, and courtesy of Al Gerard at MIC in Jackson, Mississippi. I always joke I owe him a beer every time I use this, and now I'm up to about a keg for as many times I've given this presentation. I ask you to take a look at this and give some thought to this, take a look at it, and see if there's anything that you see wrong with this tornado warning. And I don't need you to pipe up or anything like that. Just sort of look at it for a moment. I'll give you the answer here shortly. Take a look at that and see if there's anything that you see wrong with the tornado warning. All right, so you're going to want to throw things at me here for the answer, but unless you're OCD, really there's nothing wrong with this warning except for one thing, and that is if you're OCD, you would recognize that Sunday did not occur on February 21st in 2012. The answer for this question is the year. It was not issued. This warning was not issued in 2012. This warning was actually issued in 1971. And I have taken some liberties in the format and such, but the point of my showing this to you is to make this dramatic that we really have not changed our warning concepts and methodologies in over 40 years. And in writing some paper on this, I actually discerned that it's probably more like 50 to almost 60 years now that we have not changed it. The warning, all caps, text type of warnings. And yes, we've done a few things to adjust the methodology that we issue the warnings. We've done some bullet formats, so that, as I said, I took some liberties with the old warning and put it in bullet format. And we've also gone into storm-based warnings issuance, but the output from that storm-based methodology is still very similar. It's our deterministic text-based warnings. And I think we all know this bullet right here. Society has changed dramatically in those 40 years. The technology, science, diversity, lifestyle, everything has changed in those 40 years. Yet we continue to pump out text-based deterministic warning products and expect a different outcome. So what we started looking at here at NSSL is this, what are the challenges? What are the things that we're dealing with in our current warning methodologies. A lot of this grew out of the Weather Ready Nation activities and sort of spurred on by that. I'll get to that in a minute. But one of the smoking gun issue for me was this image that Greg Carbon put together, Storm Prediction Center here in Norman. In this image, you see that the pink area, if you add up all the area included in tornado warnings in 2011, that's what you see in the pink area, so sort of graphically represented there. The total National Weather Service tornado warned area is in pink for 2011, whereas the impacted area, impacted by tornadoes, is in that red dot. For me, this screams perceived false alarm. When you start talking about the area that is actually impacted versus the area that was warned on, and you see it graphically there, we have a high false alarm rate or perceived false alarm rate just in our aerial coverage. And so that sort of lends to the first bullet I've got on the screen there, that warning polygons in their current formulations are rather blunt instruments for communicating this dynamic, small-scale, and multi-phenomenon threat. I mean, granted, when we put out a tornado warning, we're not just talking tornado, we're also talking hail, damaging winds, and such. So it's a blunt instrument. It's about the best way I can say that. And then we end up doing things like this with our polygons that the end users on the receiving side really have trouble with. And I show this just as an example, not to pick on Brownsville, but I think every office has found themselves in this sort of situation. You look at this and you wonder how the poor folks in Sebastian, Texas, are responding to that onslaught of polygons. Where are they? Are they in? Are they out? Or what is their situation? So at some point they just kind of get overloaded by it all. So those are some of the challenges. Another challenge that we have is sort of what we refer to as our time-space continuum here. In the event that occurs, we have things that lead up to it, and we start doing products. And from the Weather Service point of view, we start with our outlooks, and out days in advance, and as we get closer to the event, we get a little bit more refined in time and space with our information. And so we start getting into the watches as the event starts to unfold or begin before it unfolds. And as the event does unfold, then we start pulling the trigger on our warnings. And so those are the products that we issue. But I would maintain that this is a very product-centric approach. And as I mentioned, it's deterministic, basically binary. You're either in a warning or you're not, or you're either in a watch or you're not. There is no gradation in there, so it's either all in or not. And I'm taking a risk here by using the word presumptuous, and I don't mean this in a derogatory way, but if you really think about it, it is a presumptuous approach for a meteorologist to sit there in a WFO someplace. And for those of you who know me, I'm not just from the research side. I sat there at the warning desk many, many nights doing the same thing, deciding what's best for the end user without really knowing what the end user's needs are. So when I decide to pull the trigger on the warning, it's because it's a rather presumptuous act that I know what's best for you as the end user, even though the end user may have lower risk tolerance and these kind of things. So this whole the act of issuing a deterministic warning is a rather presumptuous act, and I think there are better ways to go about this. There are also, when you go into this product-centric deterministic approach, there are these information voids. There's these gaps between the products where there's information that the end user would like to have and needs to have, while there's also information that the forecaster might have and would like to communicate. We tend to rely on other technologies to fill those voids, graphicasts and short-term forecasts and chat, NWS chat, my brain is going, NWS chat. We use other products to fill those voids, but it's not really a part of a continuous flow of information in the same way, in the same manner that the products are issued. So these are sort of inherent challenges we have in the current warning system there are many more challenges. I just don't have time to go through them, but these are some of the bigger ones that we're trying to look at and address as maybe as a future warning concept, watch and warning concept. So we landed on this sort of seminal question, and it's all, again, born out of some of the Weather Ready Nation activities. I sat in some of those meetings, and I'll be honest with you, I was a little frustrated because we were all asking the same thing, but not really looking at it in a holistic sense. So the question arose, should we continue to address these challenges, all these challenges we have in the watch warning system, in an ad hoc, piecemeal manner? I call that tinkering. So should we continue tinkering with the existing system to address those challenges, or is it time to take a new look, a renewed and rejuvenated look at the entire watch warning paradigm and do it in such a way that it addresses those challenges but in a comprehensive fashion? And that's what I refer to as the reinvention. I think the answer is probably a little bit of both. We can tinker all we want, but I would sure hope that that tinkering that gets done is toward a more futuristic vision of what that new watch warning paradigm should be. And this is really where Facets gets its start and sorts of things that we're looking at. So if we're talking about a paradigm shift, this goes back to Management 101. When you start talking about shifting your paradigm, you've got to look at certain things. Three things really go into any new paradigm. First of all, it's the good things we do now. You don't want to throw out the good things we do now. So I say first, do no harm. The second thing you need to look at are the challenges. And I've already shown you a couple examples of that. And so we need to look at do we refine, or how do we refine, revise, or reinvent ourselves in order to address those challenges. And the third part of this is the trajectories. Where are we headed? And in particular for the watch warning paradigm, we need to take a look at where science is going, where the tools and society are all going, and pay attention to those trajectories. And so what I'm going to do here for a little bit more, since we're talking about a paradigm shift, let's take an approach here with Facets that does all three of these things. First, do no harm. Don't throw away the good stuff we do, but start looking at fixing the challenges, and also make sure that we're headed in the same direction as the trajectories of science, tools, and society. So I'm going to give you a few of these trajectories that we're looking at trying to match and keep up with. First of all is the evolving methods, and some of you have heard about these things, warn on forecasts. There's work already being done on future warning information coming out of the models. Some of this is under development here at NSSL. And so that type of method of warning forecasts is developing. And in Australia, they have FESPA. In China, they're using FDP. There are different technologies and means of doing these things. Here at NSSL, there's been this idea called PHI, or Probabilistic Hazard Information. Basically, instead of doing a polygon, do it in a gridded probabilistic sense. A lot of these things are unsupported and untested. For example, sort of a moving version of PHI is the threats in motion, and there's been some work in the southeastern WFOs as well as NSSL to work on these kind of things. And even other offices are starting to work on, are dabbling in these areas. Tulsa has been exploring what they call threat pedals, and I know up in the Pleasant Hill office, y'all are working on, I can't believe I said y'all, I've been in the South long enough. You've been working on plumes. So a lot of these concepts are, if you look at this screen right here, you see a lot of similarities in conveying our information in something more than just a polygon approach. But again, a lot of these are unsupported, and the testing is ad hoc and not quite well coordinated with each other. And that's kind of an issue that I see. While there's a lot of work going on this, there's not a lot of coordination between the partners or the people that are doing these things. So I think that's an important observation to make.
Okay.
I don't know if anybody else has expressed interest.
No.
Any questions out there, or is this somebody just come off of mute? Maybe that's it.
Okay.
Because I'll do my West.
Please remember to mute your phone. We can hear somebody having a conversation. Thank you.
Sounds good. All right.
Okay, so anyway, another trajectory that we have, evolutional trajectory, is the domain. And anybody who's working WFO, you know all about this. We're on the grid already. The NDFD and these kind of things are all on the grid. Next Gen, all these other things. MRMS is going to be a tool that you're going to be seeing shortly, and if not already, many of you are already working on this, usually on the hydro stuff, but it's going to be coming more for severe convective type of things here in the next year, as a matter of fact. Weather Service has started to implement this, so it's sort of data on the grid that you can pull out and extract and do some data mining, pull information out like rotation tracks that you see here from the 2011 tornado outbreak. All this stuff is extracted from the grid. The issue here, though, is that we don't have our severe operations on the grid. But if you look at the trajectory of where everything is going in technology, the grid is the place, and we need to really start thinking about how we get our severe operations on the grid. And I think this is a key point of future watches and warnings. To that end, some of the developmental work that's being done by NOAA, in particular GSD up in Boulder, Colorado, they are working on some of these tools to take gridded information and allow the forecasters to interact. The Hazard Services Grid is sort of the next generation warning tool. Right now their emphasis is on hydro. They're pulling in River Pro and some of the other hydro type tools to make it more WarnGen-like, and then WarnGen will evolve to this as well. So this is, some may have known it as IHIPS, but it's IHIS, but it is sort of the next generation of it. And again, the WFOs are already starting to tinker with enhanced short-term grids using GFE to go after the short-range types of things in addition to what we do normally on the synoptic scale. So the tools are evolving already toward the grid and manipulating data on that grid. So your forecasters, as forecasters, we are accustomed to that already. Another trajectory that we see sort of common out there is the output. And there are a lot of different projects taking place to explore better ways, or ways to better influence human behavior. Impact-based warnings, the stuff they're doing up in Central Region, is a good example of that, but there are other things like Winter Hazard Simplification Project, and other parts of the country. There are projects that people have undertaken to give better information, and so people respond better. So that's another trajectory I see. The output, people working to figure out and come up with the best form of the output. The fifth trajectory we see is just the nurturing environment, and we've got test beds and proving grounds, places where we can try these things, the sandboxes I refer to them as. There were places where we can explore new ideas and make sure they're ready to go before we open them up to WFO and RFC operations. The roadmap that has been written up as part of Weather Ready Nation points to decision support services and pilot projects. This whole environment for testing and evaluating is really good and rich out there, and I think we need to seize on that. And again, it's another positive trajectory that I see taking place. And Weather Ready Nation in place with the new emphasis and an important emphasis on social and behavioral sciences, including those into what we do in the future of this. So here's where the Primordial Soup comes in. I've sort of jokingly referred to this. If you forgive my little gimmick here on PowerPoint, but all these various projects and trajectories and things that are taking place, each of them has energy, a pulse. They're working on their own little project, and I'm not taking anything away from any of them, but they all have energy and movement of some sort. The challenge in having this primordial soup of all these projects is that there is no guarantee that these ingredients are these trajectories are going to land at the same place. They may not be well coordinated, and in fact they are probably not very well coordinated with other projects, and there's no assurance that they're going to arrive at the same place as another project's trajectory. And so in today's fiscal climate, with the sort of funding that we have or don't have, it really is impractical for us to be doing these things without a coordinated way or in a coordinated fashion. And so I came after 25 years, jumped over to the OAR side of the house, NSSL, 25 years in the National Weather Service, jumped over here and was asked to help rejuvenate the warning research and development program. Well, I started looking around at all this primordial soup, and I'm thinking, this is driving me crazy. How in the world are we going to start getting ourselves to anything that is going to be of use to the public if we're all sort of doing our own thing? So it's just this sort of a selfish statement right here. For those of us who are trying to manage warning research and development, we need to be better coordinated on this rather than just letting everybody off going off their own direction. But I will say that all of these are united in their common desire to improve public safety. That's what every one of you and every project out there is all about. So I don't want to take that away. So what we see here is this opportunity to take a look at a new paradigm that maybe addresses and organizes these projects and helps organizes the concept into a singular vision for a threat forecasting paradigm, and that meets some of these criteria. I've got 6 of them here. I'm not going to go into what they all mean, but I think the opportunity, I think the time is right when you look at the trajectories and the science and all these kind of things. The opportunity is here for us to take a whole new look at it, and this is where Facets comes in. And we finally get to that point. And so for all of you acronym haters out there, I apologize for introducing another acronym, but I really had to because as I started making these presentations, people kept telling me, you got to give it a name. I kept calling it this warning paradigm, and they all say, well, that doesn't make any sense. You got to give it a name. So I apologize for another acronym, but there it is, forecasting a continuum of environmental threats. And as you see across the bottom of the screen there, Facets has specific components, all of which point to the watch and warning process. If you really go from left to right on those little facets down there at the bottom, you can really see that they model the warning path. You start on the left-hand side. That is how we do our warnings. You know, what's the methodology by which warnings are created. And then it's fed by observations and guidance. The forecaster makes the decision. The forecaster uses a tool to create the thing. There's output. We hope the public responds effectively, and then we go back and verify. So if you really stand back and look at this whole Facets program is all about the individual components, every step of the way of what goes into a watch and warning process. Let me put a huge disclaimer out here, because I don't want anybody walking out of this presentation thinking, oh, look what the Weather Service is going to do in the next 10 years or 5 years or whatever. That has not been decided, and that is a lot of work. There's a lot of work that has to be done before that. So the concepts that I'm going to present here are all under development and evaluation by NSSL in conjunction with Weather Service folks working side by side to make sure that what we do on the research side makes sense on the operation side. But please don't go walking out the door saying, okay, it looks like we're going to do this. We're not there yet, but we have some information and some ideas that we're jointly developing and testing that do show some promise, so that it encourages us to keep on going. So let me start with the first facet. I'm going to walk through each one of these to describe what they mean, and on the whole, then, they will describe the entire Facets concept. We start with facet number 1, and that's grid-based probabilistic threats. And I know what happens. Every time I use the P word with people, I usually get this response. We can't do probabilities. People don't understand probabilities. They don't even get what POPs are. They don't understand what those things are. Why in the world do you want to go about this? Well, my answer to that is just stay calm. There are ways that we can communicate probabilistic information in a non-numeric sense, in a non-numeric manner. So I would say don't hit the panic button on this yet when we start talking probabilities, but there are some distinct advantages to looking at our warning information in a probabilistic sense that I hope to demonstrate here through the rest of this presentation. So what we're talking about here is really what we call phi. probabilistic hazard information, phi. And basically that is taking the probability of a particular phenomenon occurring at a location or area in a specific time frame. And the probability of what is still an issue for us right now. Do we do it in 30 minutes? Do we do it in 5 minutes? Do we do it at 10-kilometer resolution? Do we do it 1-kilometer resolution? It really doesn't matter at this point. We're still going to work that all out. And so what you see on the screen here is an example of what that probabilistic output might look like. And the numbers right now, you know, I think anybody who deals with probabilities knows that 96% chance of a tornado is astronomically high for any location. So don't get hung up on the numbers or the relative scale of those numbers, but just understand that there is some number that can be used to demonstrate probability. But on this particular example, we also overlaid the polygon, and I think you see here the challenge we have with our polygons, that even when you're looking at a probabilistic sense, there are certain areas inside that polygon that really, in this example, are 0% chance. Well, why are they in the polygon if they have a 0% chance of tornado occurring at a particular location? So by going to phi, or probabilistic hazard information, we can start focusing in on the area that is most at risk. So by going this route, forecasters convey the threat probability on grids and not explicitly watches and warnings. Let me let that sink in, and don't panic on this concept yet, because there's still a way to do that. But we don't focus explicitly on issuing a watch or a warning. We are focusing more on the probabilities of a particular phenomenon occurring at a location. The good news, though, is that, again, goes back to do no harm. The culture, the public have become conditioned to watches and warnings. Okay, so we're still going to be able to issue legacy products, but they fall out of the probabilistic grids on some predetermined threshold. So yes, we will still have tornado warnings, we will still have tornado watches out there, but they are probably going to be in a polygon or an area much smaller and more focused on where the actual threat might be, and based on some predetermined thresholds. Again, it will remove the forecaster's emphasis on warn or don't warn. It basically is a continuous flow of information going out. What it also opens up by doing this probabilistic approach is it opens up opportunities for new products and services, so things like proximity alerts. So if somebody has a low risk tolerance, like a nursing home or a hospital or something like that, and they want their thresholds down, or then their thresholds are lower than what maybe the general public's might be, they can respond according to whatever probabilities they have set for themselves, or we help them set for themselves. So this going with the phi approach opens up the door for new ways of communicating information. And yes, again, after 25 years of the Weather Service, I get that this is a huge paradigm shift for operations, and what we're talking about here is rather revolutionary. There's going to have to be a whole bunch of training. There's going to have to be new tools for the forecasters. And one of the things I think is a cultural thing is going to be that forecasters may have to come to grips with the fact that they are not the decider of the warning anymore. They still communicate the information. They put it out. They are the forecaster, but there's always that little bit of pride of being able to be the one that makes that warning decision and push the button. I am the one that decides. Again, that goes back to that presumptuous kind of a notion that there may be people who need to know that information earlier than you decide. So we have to come to grips with just that sort of mentally and culturally about how we deal with that. So that was facet number one, grid-based probabilistic threats, and the methodology by which those warnings are discerned. The second facet is what the forecasters use to make the decisions, and this is a huge bucket, observations and guidance. It's a huge bucket because it includes radars, models, guidance, surface observations, satellite information, you name it. Whatever we use to make our decision as a forecaster falls into this bucket. So it's a big one, but I'm going to focus on one particular aspect of it right now, and this is what is coming down the line at some point. It's called Warn on Forecast, and it's really numerical weather prediction for storm scale processes. And as we started talking about this here at the lab and realizing what they're doing on warn and forecast, I kept asking the question, okay, so you get this ensemble output from the models that shows where the greatest probability is for vorticity. My question was, then what? What does a forecaster do with that? Does the forecaster take that information, turn around and issue an all caps deterministic textual product, or do we do something different? So again, this is sort of the spur behind Facets, is that if we are going to go down this path with warn on forecast, ensemble output, and trust me, that day is coming as soon as our technologies catch up, we need to have a delivery mechanism for that type of probabilistic output that goes beyond the text-based all caps deterministic information. And so Facets we view as the delivery mechanism for warn on forecast generated output. There are other things that are at work here at the lab. One of these is called mirrors, multi-year reanalysis of remotely sensed storms. I always call this a terrible acronym, but a great idea. Basically, what we're taking is 15 years of radar data, NEXRAD data, and doing a reanalysis to get some statistical output of storm scale behavior. Let me put that in easier terms. I look at this as real-time storm scale MOS, so that as you're sitting there looking at the radar, the statistics will be able to say this type of storm in this type of environment typically does this, whether it's a phenomenon or longevity or how severe it's going to be. There will be probabilistic output for a forecaster to make some sense of what's the future of this storm based on climatologies. I'm really excited about that, and we're probably 2 years out. In fact, we're going to be testing some of that in the hazardous weather test bed this spring and into the fall. So we're probably about 2 years out from really seeing some results to go operational. It does pave the way, if we're talking probabilistic output, it does pave the way for this warn and forecast probabilistic output. So again, this whole notion of probabilistic output and Facets being the delivery mechanism for it is important. All right, so this observation and guidance doesn't only come just from the models and such, and from statistics. It's also from each other. Storm Prediction Center up here takes a look at all their information and comes up with synoptic and mesoscale output. That information is also looked at by the WFOs and RFCs, and for severe convective in particular, it's WFOs. And there is no reason whatsoever that the grids that get generated by the WFO can't be initialized by Storm Prediction Center input. So we're all on the same platform. We're all in the same grid structure. These grids may be a little more coarser in resolution, but handed down from the SPC to the WFO. WFO then uses that initialization to update their grids and therefore create the output. What we have here is this continuum, this information continuum from large scale down to small scale and in integrated fashion all the way across. So there are some distinct advantages in doing it that way. All right, so that was the second facet. I glossed over. There's a lot there. The third facet is the forecaster, and I wanted to make the strong point that the forecaster is in the mix in all of this, and in fact I think probably going to be over and in the grids and as essential as ever to the entire warning watch process, because there's going to be a whole host of information coming in. You got to make sense of it. You got to turn it into something that the end users are going to be able to make sense of as well, and so the forecasters are going to be deeply embedded in this whole Facets approach. Again, as I mentioned before, there's going to be a whole lot of training that's going to have to go into that and getting us on board, and we have to budget accordingly and staff accordingly to make sure that those things happen. All right. I didn't spend a lot of time on that, but the amount of time I spend on that is not any indication of the importance of the forecaster in this whole Facets concept. The fourth facet is what we call threat grid tools, is what we use to create the forecast. I've already kind of covered some of this already with the Hazard Services AWIPS-2 tool that is being built by GSD. it's really WarnGen for threat grids, or RiverPro for threat grids, basically all melded into one. What we are trying to do, and we are actually succeeding in this, is that we are building our connections between NSSL and GSD and the Storm Prediction Center to make sure that the watch warning concepts of these tools make a lot of sense and have the best science behind them to show forecasters, give the tools the tools to understand where their threats are and to convey that information to the end users. So we are strengthening those things. I just sort of a little dirty laundry here. We probably weren't as strong on that in the past, but because of what we're doing with Facets, I think we're improving those relationships. All right, the sixth, 1, 2, 3, 4, 5. The fifth facet here is the useful output. None of this will do, the first 4 facets will be of little use if we don't generate output in a fashion that the end user can make use of. And I'm going to give some examples here. A lot of them may be more private sector type of things, but we can stay relevant in this whole game by the National Weather Service issuing information in this grid-based probabilistic approach. So as I mentioned earlier, yes, watches and warnings will still be issued, but they may be smaller and more phenomenon-specific. They will allow the end users to specify their own thresholds for whatever warning they may want to get, whether it's a Weather Service warning or end users defined for themselves. And in some ways, by not having a deterministic warning issued, the end users can establish longer, although it's non-warning lead time, they can establish longer lead times based on the information, the relative increase of risk or threat communicated to them. I'm going to show a couple examples that maybe have that make more sense. And by doing this, we can focus on the impacts as well as the meteorology, and not so much on the products, as we've been trying for a lot of our work with the decision support services and such. So I look at this as a way to better communicate the impacts. I would envision, based on technologies that are already out there, that you could build a GIS-based impact translator tool to extract, the relative threat at this location versus what type of risks are in that location. I'm going to give an example here that will make more sense. So we have a forecast, a high probability of wind gusts to 70 miles per hour. Well, you go into your GIS database and you realize in there automatically that there are a lot of trees. It's in an urban area with a lot of mobile homes. And so your language gets crafted in such a way, automatically pulling out of this GIS database that says something like numerous trees and branches will fall, roofing material will be peeled back, unsecured mobile homes will be rolled, because there's a lot of mobile homes in that area. So you tailor your information to the end user based on the probabilities of the phenomenon that will occur, as well as what the GIS database says exist in that area. So what we're looking at here is the information that gives more useful, actionable, and recipient-specific guidance for what they can expect, and it's more focused on impact. Again, as I mentioned, the SPC is already tinkering with the gridded outlooks. I wish I would have had a better example here to show you, but day 3 to day 2 to day 1, as we get closer to the event, the outlooks are gridded, so you could envision some sort of display like this for an end user. And I noticed the location. I picked at 4701 North Porter. When I first moved to Oklahoma here, that's where we were staying. That was our apartment. So you could envision at a specific location a relative threat grid, or a relative threat histogram here. It's not a histogram, a meteogram that shows when are the relative threats the greatest. And by doing this from a gridded format, it's a lot easier to generate something consistent like this that the end user becomes accustomed to and is familiar with seeing, so that they would know, well, okay, they're between day 4 or around day 5 is where I really need to start paying attention and worry about things. So as we get down scale from the large-scale Storm Prediction Center, we get down to the WFO level. This is sort of an animated version of what you saw earlier. This is an earlier iteration of sort of the threats in motion, fee, probabilistic hazard information. And I draw your attention to that little white box. Again, that's where 4701 North Porter is. And you can see at that location the relative threat of a tornado, in this case, changes. And it can change on a minute by minute. I think in this case we did it like every 2 minutes or every 3 minutes. So you can foresee the end users having information flowing to them in a continuous fashion that shows something like this. You get down to the time scale of when is the tornado risk the greatest, and hail threat the greatest, and wind threat the greatest, and so on. Now, I know what you're thinking. We don't have the skills to do this yet. And yes, we don't have the skills yet to do this, but we can convey this information in a probabilistic sense and show some error bounds around these kind of things. And I will also acknowledge that this is not the type of thing that you're probably going to expect your mother-in-law to look at and understand, but this is sort of targeted to more of the sophisticated users and who might have a phone app that says, here are the threats at this particular location. So you can envision then we take this scale, look at the upper left-hand corner, you see starting on day 8, and we work our way down scale, SPC outlooks doing this sort of thing, and then working our way down to the phenomenon itself where the WFO takes over, and then start putting out this information in a high-resolution grid like this. Now, I will say there's a flaw in this particular animation in that we don't cover the area between what SPC does on the regional scale, like their outlooks, down to when the warnings are issued. And this is that gray area between that some of the research is being done on now with the HER model, some of the mesoscale or subsynoptic scale information that can be to add information in that gap between the larger scale information down to the warning scale. So we're going to come up with a better animation on this that takes it the evolution of the event down scale, and you start honing in on an area until the warnings start getting issued. I don't like this slide, but it's the best one I had for the time being. What we are doing now is realizing that warn on forecast and actually the MPAR, phased array radar, actually improves the output for warn on forecast, and then warn on forecast then feeds into Facet. So what you see here in the contours is output from the ensemble saying where's the highest probability for rotation. And based on that output, then you can start inferring a path, storm path, and then overlaying your Facets type grids on that. So at each grid location, there's this information, and you can update every 2 minutes or every 1 minute as that information, new information comes in, and you start seeing things like this. Again, back to the meteogram that I was showing earlier, probability of a tornado in a particular location, and with some error bounds around it that need to be scientifically based error bounds, but they give the end user some sense of what the relative risk is here. So what I want you to understand here is that we're talking about Facets as an information continuum, not a product-centric deterministic watch or warning, although those will still fall out of the grids and still be used by the end users. What we're really thinking here is a continuous flow of relevant, actionable information, updated frequently and continuously throughout the event, and starting from days out in advance all the way down to minutes and seconds, so that you can envision somebody sitting there with a little phone app on their phone saying that in the next 30 minutes at my location, GPS assisted, basically saying here's the relative risk right now in the next 30 minutes, and then updated every 2 minutes or 5 minutes or whatever, then saying later on, boom, hey, you got to pay attention, this is for you at your location, here's your relative risk, and then you could foresee additional information about what you should do based on that risk or that information. Now, this is a huge area where private sector steps in and helps us and assists us in that, but guess what? It's the National Weather Service feeding that information out, staying relevant to the warning process and a major player in the whole warning enterprise. So the useful output is important. Again, the output will mean nothing if we don't get the public to respond in the right way. And this is where I start bringing in a lot of the social science and behavioral science aspects of it. I say I bring it in here, but it's really throughout the whole process. I'm going to explain that here shortly. Jeff Lazo, social scientist, if you will, from NCAR, I think coined that phrase. This is not reference because he told me this in person, and I like the way he said it. And to paraphrase what he stated here is that, you know, people are just going to do dumb things. People are going to respond in a certain way, and there's nothing you can do to change that other than to build a system to address that, to deal with the reality of the way that people respond to information and make sure that they have the best information and respond accordingly. So what we're looking at here as a result is, another way to say this, as Russ Schneider said, start at the end of the desired response and work our way backwards from that. So if we have a response, the public's on this track, we have to look at things like education, preparation, awareness, understanding, all these things that the public follows on their track. And what I just described is, with Facets, is the forecaster track. That's the bottom line here. The method, the guidance, the decision, the tools, the output, intersecting at the public's spot for the response, and make sure that their response is what we want them to do. So we build our system to make sure the response is there. Well, how do we do that? We make sure that we have social science integrated throughout the entire warning process. And I kind of refer to that as the Facets epoxy. When you integrate social and behavioral sciences with the physical sciences, this whole system becomes stronger. Now, I've got a lot of disciplines here, and this is the one thing we always fault ourselves on, is that we always point to social sciences. Well, it's not social sciences on the whole. It's every discipline of social science has a place to play here. In fact, I'm sitting in the room with an economist. Kevin Simmons is visiting me here today, and he's an economist, and we are working on figuring out how economics and human behavior fit into this whole model. And so you build your system accordingly, so you don't just do this as a bunch of meteorologists sitting around figuring out what's best. You incorporate the right type of discipline of social science at the right place. And that is a part of what Facets is trying to do here. I'm going to give you an example here. This is hot off the press. In fact, on Tuesday we were presented with, I haven't even gone through this in animation mode. We were presented with some results from some of our human factors people who took a class through some of their classmates. About 36 OU students went through and did a survey, or participated in a survey to look at 6 different things here about determining their threat and their risk and how people respond and react to information. This is what human factors people do. They give them a piece of information and they say, well, what's the likelihood people are going to respond the proper way? So what they did in this survey is they looked at 6 different scenarios here, and you can see them. They called it cone. Basically, it's the fee type information with numbers, without numbers, in moving or not moving, so stagnant or moving. And then they compared that against polygons, the way the Weather Service does it now. Polygons either moving or stagnant, and just to see how the end users would pay attention and respond to that. Their questions were, given that you are in one of these polygons or in one of these areas, they wanted to discern what is your risk level, for if they can discern what their risk level is, and how long it takes for them to the tornado to reach their location. So it's about comprehension and basically determining whether they can comprehend their risk and how long it will take for the tornado to reach their location. And then they also wanted to measure how long it takes for somebody to figure that out. So in this survey, and I don't have time to go through all of this, in this survey, this is just one of the questions for the stagnant cones. They asked the question, what best describes your current situation? And I wish they wouldn't have used the word risk, because all us meteorologists think of it in a different way. But basically, they asked them, if you're in that blue dot, if you are that blue dot in this area, what do you describe as your current situation, and how long will it take for the tornado to reach your location? And then they graded them on how best they answered. Did they answer appropriately or accurately or not? what jumped out at me from these results is this diagram. By just doing stagnant polygons, 68% of the responders got the right answer. 68% understood that they were at risk and such. But if you used cones, or cones with numbers or without numbers included, that number jumped extraordinarily. So even if it's stagnant, by putting cones, a gradation or gradient cones, or plumes, whatever you want to call them, if they have numbers or they don't have numbers, the end users interpret the data much better than just looking at a polygon. I think from a meteorological point of view, we kind of always knew that, but it's so nice to have human factors people validate that for us, that polygons are open for misinterpretation, but if we go with phi, the probabilistic hazard information, even in a color scheme or with numbers, the possibility that the end users will understand it increases greatly. I don't have time to go into a lot of the details on this. This is just like I said, hot off the press. I want to do a more thorough analysis on this, more than just 36 college students, but that's what you start with. But the initial results are intriguing and such. I'm going to jump past here just in the interest of time. So what they have come to is that through objective measures, the public or the end users, these participants responded best to stagnant cones with numbers included in them, but subjectively they like the moving part as well. So the best display is a stagnant cone with numbers, but moving doesn't hurt either. All right, that was probably way too much to throw into this presentation, but that was sort of a new wrinkle. The final facet here is verification, and we want to make sure that what we do makes sense and is easily verifiable. The advantage of going with grid-based verification is that our forecasts and our observations are on the same coordinate system, a geospatial grid. And by doing that, we can do things, we can explore things like reliability. We can pull out all our statistical approaches like Breyer scores and have a much better and more statistically valid and scientifically robust analysis of how we are doing our job. And it actually opens up the door for new metrics like false alarm time and area and site-specific lead time and these sorts of things. By going grid-based, we're going to get more quality, better quality verification than what we're doing with our polygon or deterministic forecasting and warning approach. So there it is. Facets then, if you remember the primordial soup, of all these things that are floating around out there, if you remember I said at the very outset, facets is also a construct for us to organize for a path forward, a progress forward. If we take that primordial soup and start putting it in the bins and say, okay, go do your thing, go do the threat pedals, do your hazard simplification, whatever you're going to do, but make sure that's all pointed toward ultimately grid-based probabilistic information that that Facets is designed to do, then we are much better coordinated in what we do. And this is my appeal to all of you on the Weather Service side. If you've got ideas for projects or want to work on a study or something like that, let's do this together. Bring National Severe Storms Lab into the game, into the mix with you. Let us help you. Let us work with you, and let us do this in a coordinated fashion, rather than what we tend to do is kind of all go off in our own direction. But this Facets then is integrating social sciences throughout the process, bringing social and behavioral sciences into the mix, and utilizing the resources we have out there. We've got hazardous weather test bed, we've got a proving ground, we've got pilot projects, and we've got a whole load of field talent out there. It kind of goes back to my statement I just made about leveraging that field talent, working with us to develop this Facets kind of continuum and develop a robust new future warning concept. But it all really starts in this concept with Facets is the grid-based probabilistic. We start with phi and move from there. I'm going to use this opportunity to make an advertisement for the virtual lab that MDL has put together. There is a virtual lab with a community, a Facets community, where you can join with this community and start exploring with us, share ideas, and see what we're working on. You can get this presentation. You can see other things there that we're doing on the Facet side. So if you haven't done it already, go on to Virtual Lab. It's a Weather Service thing. And get into Virtual Lab and then join the Facets community. And there are other communities out there. There's AWIPS 2 communities and other things. But I encourage you to join us on the Facet side. So the expected benefits from Facets is this continuum, information continuum from days down to minutes and even seconds, from large scale down to small scale. I fully expect to see the false alarm area reduced by at least 30%, that pink area that Greg Carbon had in his diagram here. Once we start focusing in on where the threat is greatest, then I would expect that threat area reduces by at least 30%, or the false alarm area is by 30%. So Facets has this delivery mechanism for warn on forecast and other research to operations activities. Facets will also help us address a lot of the Weather Ready Nation identified issues. Some of the issues that were there sort of speak to a reinvention versus just continued tinkering with our existing system. I see lots of private sector opportunities, so we are going to partner, and we already are partnering with private sector folks to come in and help us design this and build it in such a way that everybody benefits and it works best all across the warning spectrum. And this is my motherhood and apple pie statement down at the very end. So, as I said in my summary, but my very first slide said, Facets is a new watch warning paradigm focused on grid-based threats. The second thing is it puts it into a framework intended to organize and guide whatever reinvention efforts are out there. And I've gotten Weather Service leadership attention on this to help organize, and that's a good thing. And then again, another motherhood and apple pie statement here. It is really the means for improving and enhancing your high-impact weather forecasting services. So where you come in, as I already mentioned, participate in hazardous weather testbed experiments. Join us this coming year. It's next year. It is next year for the future. So when you see the announcement come out for hazardous weather testbed, join us on that, coordinate with us, and then follow us on Virtual Lab or VLab. So there it is. I made it under the 1 hour thing. Just barely. I probably prattled on longer than I should have, and I didn't leave any time for questions. But, John, I'm going to pitch it back to you and see if we do have time for questions.
Thank you very much, Lance. And actually, we did make this an hour and a half, so we can take questions. I would, as the host, I think I'll go ahead and actually ask you a question first. Do you see these concepts being applied to other areas of warnings? For example, winter storm or marine warnings and so forth?
I'm so glad you asked that question, because I always forget that as I'm going through this presentation. You see the title. It's the name Facets, Forecasting a Continuum of Environmental Threats. While the focus of my presentation is on severe convective type of things, it's also hydrologic, it's also winter weather, it's also fire weather. It is intended and designed to be all-inclusive ultimately. Right now, to get our baby steps going on this, we're focusing on the severe convective. Granted, I'm from the Severe Storms Laboratory, so guess what? That's where I focus my energies. But in talking to the folks like Eli Jacks and other folks up at Aquas and Weather Service headquarters, the intent and the vision here is that this does bring in the winter weather types of aspects and all environmental threats as well, not just severe. It's not just about tornadoes. Thanks, John, for bringing that back out on for me.
You're welcome, Lance. Okay, let's open it up to questions. Anybody has anything, just speak up, please.
Lulled them all to sleep.
Hey, this is Al at the Sioux in Pleasant Hill with a question.
Go ahead, Al.
Go ahead.
Yeah, thanks. Hey, really enjoyed the presentation, first of all, Lance. So thank you for that. My question is, and you brought this up earlier, we're one of the offices you mentioned up here where we've got our ITO has been working on some plumes, if you will, from a threat aspect based on our warnings and such. But based on the direction of where you guys are going and the focus, which I don't disagree with, but for offices like ourselves, and who should we contact on at NSSL to say, hey, we've been doing this. Is this something that might benefit you and your efforts there, or what's the best approach, I guess is what I'm asking, to get the information that my ITO, Mark Mitchell's been working on and share that openly with you all down there?
Yeah, and I know through talking to Mike Hudson and Kim Runk and others that you've been working on that, and to answer your question quickly, contact me. But Greg Stumpf and Travis Smith and some of the others that are in the unit that I supervise, they're the ones that are spearheading all of this, and I know they are aware. In fact, we actually wanted to make a trip up to Pleasant Hill. It just hasn't happened yet. Sit down and talk to your ITO and have that conversation and see what you're doing. Again, I want to be really careful not to say that, stop what you're doing, but do what you're doing. Let's just make sure that it's pointed in the same direction, and help build what we're trying to do here. You can be certainly a participant in building the Facets kind of concepts, and we want to leverage and learn from what you've already done and learned as well. So the immediate answer to your question is get in touch with me. My contact information is there. Join in on the VLab. And if he hasn't already, I think there has been some interaction going on already, but between us. But we need to strengthen that. So I welcome that.
All right, very good. I appreciate that, and we'll be getting a hold of you, and I know Greg and Travis as well. So we'll be in contact real soon. Thank you so much.
Excellent. Thank you.
Yeah, Lance, that's a good point about the virtual lab. We would really recommend everybody take a look at that, and we can send out information on that if you're not familiar with it yet.
Lance, this is Dave Hintz up here in Aberdeen. A question concerning the useful output. When you were talking about having user-defined output that would be available, when you specifically looking at hail, do you see somewhere down the road taking this to probabilistics of like greater than 1 inch or greater than 2 inch, or simply keeping this a yes, no on hail? If you look at greater than 1 inch or greater than 2 inch, is that going to be a forecaster-derived grid? Is that going to be populated with a high-res model? I guess where do you see that going?
I see it going in just the way you described it. That let me back up here and kind of give you a little history. We tried in the hazardous weather test bed for forecasters to sit down and just draw the probabilities from scratch. It failed miserably because, well, as you can well imagine, with no basis, with no guidance to back them up, it was a really hard thing to do. Not that they couldn't do it; it was just really hard to do. So we envision, yes, that there will be probabilistic grids for hail of certain sizes, 1 inch, 2 inches. What those thresholds are and what those sizes are, we still have to do some research on that, figure out what makes sense to not only us scientifically and meteorologically, but also to the end user. But to expect that the forecaster is going to sit there and draw those grids from scratch, it's just not going to happen. There's going to have to be some guidance, some initialization. We do it all the time now already with GFE. We sit there and we initialize our grids with model data. So I see that exact same thing happening on the storm scale here, that the high resolution ensembles like Warn on Forecast or statistical output like mirrors is going to be feeding the forecaster initialized grids from which the forecaster then can look at the radar and adjust those grids or just let them fly as necessary. So it's exactly what you described. I think that's the direction we're all headed. Did I answer your question?
Yeah, you sure did. Thanks.
Hey, Lance, this is Chris, the WCM in Central Illinois. Question for you about your second facet with observations and guidance. How do you envision that trained storm spotters and emergency managers and their reports in real time would fit into this concept?
I don't know that that would change all that much. And I'll qualify that here in just a bit. You know, first, do no harm, right? If you got an excellent spotter system, you got people pulling in reports and sending you reports and calling you and doing all that, the standard WFO operations in that regard, I don't see changing. That's just another form of observation that's going to come in and inform your decisions. Having said that, if you haven't picked up on the MPing wave here, NSSL has developed some of the MPing applications. If you don't know what that is, go on Google MPing. We're seeing a whole lot of success of spotters feeding in severe weather information, hail sizes, and all these kind of things. It was initially intended for winter weather type of precip type of reports, but we have now branched it over to the, oh, thank you, John. Man, good, man. We branched it over to severe weather reports as well, and those reports are going to be coming into an AWIPS workstation near you, man, I hope within the next month, but we're just on the verge of doing that. So there may be new tools coming, new high-resolution reporting type of tools that could be utilized and incorporated into this as well. But just for the basics of how do spotters respond and emergency managers report and that kind of thing, we haven't thought that through, but if you got ideas, you know, share them with us. There you go. John's got the MPing reports on the screen right now.
Yeah, I've seen that, the MPing. I'm familiar with that, and I was just wondering how that would be quantified, but yeah, I see how MPing could really play a role in this. So thank you for your answer. Appreciate that.
Yeah, you're welcome. Good question.
Hey, Lance, this is Ray Wolf up at Davenport. You know, I know for these sort of demo presentations, you show the supercell and things work out really neat and compactly, but you know, we're in squall line land up here.
Yeah.
Have you done any work or effort or thought processes and how in these more complicated convective scenarios this would play out?
Yes, we have, and keep in mind we're taking baby steps here. Keep it simple, keep it clean, but fully knowing that we're going to have to take a look at squall lines and QLCS and everything else that gets thrown at us. In fact, I've given this presentation to Louis Uccellini a couple times now, and he cornered me and pulled me aside one day and says, if I see one more central plane supercell example on this, I'm going to throw up. I thought, okay, I got the point. We have to, and we do intend to do some of this. What we're looking at with mirrors in particular is doing a climatological analysis, you know, of different storm types. So it'll be squall lines. It'll be included in this. And given this type of squall line, where do you expect the hail to form or fall based on, you know, the hot points in the squall line? So your question is a very good one, and we acknowledge that, we know that, but we got to start simple, visibly and physically. Just start looking at the supercell approach, and then we're going to start digging down into the squall lines. It's going to get messy, no doubt. I fully expect that some of these probabilistic grids for hail, for example, or for winds, are going to be very messy, but that messiness includes information far and above what we are able to put out now with a polygon or with our text information. So we need to expect that, but also be ready to manage that information most intelligently. Any other questions? Yes.
I'm sorry. It was a great presentation, by the way. I think, I don't know if you guys have any timeline for this. I think it's great information. I think where we fall short as an organization is getting the word out. You know, for instance, here up in Grand Forks, obviously we deal with a lot of blizzards, and last Friday we had a blizzard watch out, you know, almost 24 hours in advance, and we had people get stranded. You know, how to convey that and getting it out. You know, I don't know if you guys have thought about, you know, getting this on social media. Even before we get the information, I think we need to get it out well in advance to train the public.
By the information, you're talking about the warning information or the threat information?
Yeah, both. I mean, I think everything, getting it out. And I think people are really now getting high tech with their, the phones, and they're connected all the time to social media.
Yeah.
I think personally people are getting more information from social media, Facebook, Twitter, than they are even from our websites.
Right. And what we need to do, and again, this goes into facets 5 and 6 there, is to make sure that we are leveraging the technologies that are out there and getting people to respond in the best way possible. They're not carrying weather radios around on their hips or in their pockets. They are carrying cell phones, and we need to figure that out. They're using social media and such. And this is where we need to have some research ahead of time. And, in addition to what our life experiences are out there, you are all out there in the front line and learning these things. We need to fold that knowledge back into how we build this system to make sure that it's fully integrated.
Yeah, I'm glad you guys have thought about that, and I agree. So thank you.
And don't presume that we have thought of everything. So this is another reason why I'd love to have you get into VLab, or just by contact me or Greg or Travis directly. Engage us in those conversations and those ideas. VLab is going to be a great place. We've got a forum in there for dialogue and discussion. It's a great place to bring these questions out and to start floating up ideas and incorporating them into our thought process here. We've got a lot of smart people here, but I guarantee you they're not thinking of everything the way you all are.
Thank you.
Yeah, hi, this is John in Jackson. There are two things I was thinking about. Is number one, some people only have weather radios, and that's all that they're going to have. The other thing is a lot of counties, when they blow the sirens, they do it county-wide. And the third part is that all this stuff looks pretty good, but what about places where you have huge radar holes, where you don't have good radar data? What do you do for them? We just write them off?
No. I mean, the whole intent here is that we're not chained to one particular observation system. In fact, John's got this up on the screen. MRMS is designed for that purpose, that it's not just radar. It's not a single radar source, but using other tools. And the models don't care really if you've got a radar void area or not. The models are going to behave based on the input that they get. So there will be gap-filling information that we are going to have to use in the severe convective side as well. And let me go back to your statement about weather radios and such. And again, it also goes back to my statement, first do no harm. We'll have legacy products. They will still come across weather radio. Sirens will still be sounded probably the same way they always have been. Hopefully we can coach our emergency managers. Lord knows I've tried for years to try to coach emergency managers of when to sound their sirens and when not to, but that's going to be an ongoing process that you all on the front line are going to have to work with us on. But what we're trying to do here with Facets is to address the legacy systems, like weather radio, like sirens, as well as move ourselves forward with additional information for the newer technologies. We've got to do it all. And that's a large order, I realize, but we have to do it all.
Hey, Lance, this is Dan Baumgart, the SU up in La Crosse, Wisconsin.
Hi, Dan.
Hey, great presentation. I just like thinking about this stuff. It's nice to kind of open up our minds. One of the challenges I think about with these plumes and the cones is trying to keep that customer that's in the 5 or 3% bin at one time engaged enough to see the ramp up to 90% and the tornado coming at them. Have you thought about that or had discussion on that? How we engage those users that may be in a very low threat at one point to keep their attention span, and especially these days we're going to have this, you talk about this information continuum, we have this attention span continuum too, where maybe the higher end user may stick around looking at the probabilities changing, but how can we keep people engaged to keep receiving that information as those plumes change your probabilities? Do you have any thoughts on that?
Yeah, well, I have many thoughts on that, but by the same token, I want to be careful not to say that we have the answers. Again, this is where the social behavioral science people come in and help us design the system so that we do keep people engaged. Or, and this is Lance's thoughts here purely, is that or we recognize that people aren't going to stay engaged the whole time, but other people will on their behalf. This is where the social media type of thing comes in. I guarantee during a severe weather activity when I was in Peachtree City, I was in the office issuing warnings, but the most popular person on Facebook at that time in our neighborhood was my wife, because she was keeping a track and watching what was going on, and she was sharing the information. She was an arbiter on our behalf to get that information out. So, you know, people didn't necessarily pay attention to the weather. They paid attention to people who they knew. We need to learn how to leverage that, and there's not necessarily anything wrong with that. That's just the way things are. That goes back to Jeff Lazo's statement about you got to understand how people respond and then build the system around that. So I don't know if we have the answer to keeping people fully engaged in the weather part of it, but they sure can be engaged when people that they know are calling them and telling them, hey, this is you got to pay attention. We got to figure that part out. I don't have the answer for that, but that's where the social science comes in.
Hey, Lance, this is Scott in Goodland. How are you doing?
I'm doing fine, Scott.
Hey, first of all, two quick comments. The first is I really appreciated the vision here that you are given. You know, we got the strategic plan and the weather-ready nation stuff and a lot of lofty language in there, but nothing concrete. So I do appreciate that you do have some concrete proposals here, and even though it may not be totally the way we go, I do appreciate that we finally have something tangible for the weather-ready nation. That's an accomplishment in itself. Secondly, don't take this as a criticism, but you really give the forecasters a short shrift there in your presentation. You have a lot of neat graphics and everything, but you only give about 30 to 60 seconds to the role of the forecaster, so you may want to beef that up, just in my opinion.
Well,
here's my question. I think you and I would agree that the technology and the research here is going to keep improving, and it's going to get to a point where we've succeeded in a lot of the goals you stated. The challenge is going to be the cultural aspect of change in the Weather Service. What can we do now, other than VLab and the test beds? What can we be doing now, day to day, to get our folks prepared for these big changes? Even if it's not exactly what you're spelling out here, I think we all agree change is going to be coming. What do you think we could be doing day to day to get our folks ready for some of these big paradigm shifts?
Big question. This is over the top of any type of meteorological and scientific thing. This is just about change management, who moved my cheese, you know, type of thing. That I like your question because it gets to the heart of what we do culturally and what we have to be ready for. We have to condition ourselves. I'm not saying condition forecasters, condition all of us for the eventuality that things are going to change and be ready for that. How do we adapt to change? How do we respond to change? And the more we have conversations amongst ourselves in our local offices about that, I think the better prepared we will be. I mean, I struggle with this all the time as an MIC that, you know, I see a change coming along. We try to get the staff to come on board, and some would fight it, some would, you know, just sort of passive-aggressive sort of thing. And it's the nature of, it's a human nature of resistance to change or acceptance to change that I think there's some management stuff, some training stuff, some things, some issues that we're going to have to look at as well that basically supersedes everything Facets has. It's just how do we adapt as an organization? Because if we don't adapt, I think we all know this, if we don't adapt as an organization, we are going to be left out in the cold and somebody else is going to do it and we're going to be wondering what happened. let me go back to your forecaster thing. I absolutely agree with you. The purpose of the forecaster facet there is more for the training, what goes on in the forecaster's head. If you're really, if I really stand back and look at this, facets 1, 2, 4, and 5 are all forecaster involvement. Even 6 and 7, forecasters embedded through all of those things. The purpose of number 3 was to sort of stress the point of the training and the and bringing the forecaster up to speed on things. But you're right. I gave it short shrift, but I think I hope I can acknowledge here that it's all forecasters involved across the spectrum in the entire Facets program. So how did I do on that one, Scott?
Oh, you tap danced very well there, Lance. Very good. And I do agree with you. These are all big issues, managerial leadership issues. I was hoping you would have something maybe concrete that we could be getting our folks focused on, whether it be something like probabilistic, getting more involved with probabilistic forecasting. Obviously, the whole cultural change thing is going to be a very big challenge, but there might be some things, smaller things that we could do operationally that might get our folks more attuned to working in some of the concepts you mentioned here in your presentation.
Well, I like that idea. I really do like that idea. I haven't given that thought. We got the advantage of having a warning decision training branch here in the building with us, and we talk all the time. This may be something we bring up to them about just as a starter kit, just as forecasters, well before Facets becomes a reality, but how do forecasters engage with probabilities in the severe realm? I like that idea. So keep me on the hook on that one. Send me an email or something. I may want to follow up with you on that.
Hey, Lance, this is Ron here in St. Louis. I want to follow up on Ray's comments and also Dan's comments here. Bumgard up there. I think one of the challenges we're going to be facing in the future with this whole concept is the speed of the system. We never addressed that too well. And, for example, not only convective lines, but even supercells can go at great speeds of 40 to 50 miles an hour, if not greater sometimes. I kind of look at things like little hot spots along a convective line, where I'm thinking maybe we could find 3-4 mesovortices that can spawn snails at one time. I'd say, but they can be moving at great speeds here too as well. I just wonder how the plume is going to handle, at least the guidance is going to handle something like this. This is, I know, a little known. This is down the line here a little bit, but I think one of our challenges is going to be the speed of the system. How do you think they're going to fly across Missouri, Illinois, Indiana, whatever, and so forth?
Yeah, I think that's some of the science no, I don't think that. That is some of the science that's going to have to be shaken out of this and learned as we get into the more complex type of events. I'm still cautiously optimistic, and maybe naively so, but cautiously optimistic about mirrors and some of the output. The speed at which you're going to get the output from that is on the order of every 5 minutes, giving you sort of a downstream probabilistic sense of what might be happening. So, but we have to, keep in mind, it's still going to come down to the forecaster doing their job with the radar or whatever rapidly updating information they've got, and the guidance information is going to have to run to catch up with it in some cases, both in real time and basically in development concept. So, yeah, you're right, Ron. We have some work to do yet and some things to explore and learn. What we're doing here is sort of laying the foundation for all of that.
Okay, thanks very much. Yeah, I want to talk to you about that down the line, maybe with a phone, over email, something like that, too, a little more.
Yeah, please do.
Any other thoughts or questions or comments for Lance on Facets?
Hey, Lance, this is John up in North Platte, Nebraska. Thanks again for the presentation. Really good presentation there.
How can I pick up?
Hey, I have a question for you. what down the line, what kind of platform do you envision this all running on? I mean, AWIPS 2 type of thing, and how is all this data going to be integrated into the process?
Yeah, great question. I'll just say it sort of categorically here. We don't do anything now in NSSL in our development stuff unless it's going to be aimed at AWIPS 2 or AWIPS 3 or somewhere. We have to aim at where the Weather Service is going to be. And so, in fact, in our hazardous weather test bed, we have 7, I think, AWIPS 2 workstations that we use. So our aim is on operational platforms, not something on the side. We've gone down that path many times in the past, and I've even tried it myself in WFOs I worked at, and it's always frustrating that you've got this other system off to the side that doesn't get incorporated into the operation. So we have to be on the same platform as the WFOs and the forecasters are.
Okay, thank you. Also, do you foresee this being facilitated at 122 different sites, or, I mean, is that where all the data integration will come, or will there be something more at a centralized place?
We have to work that out. I'm seeing the answer to that is both. I'm seeing some centralized sorts of things, and I'm seeing enough horsepower at local offices that some things can be handled locally. So it's going to depend on what information, what data we're talking about here. But again, some of the mirrors things show some great promise of being rapid and portable to local offices.
Okay, thanks. This looks really good. Thanks for giving this presentation.
My pleasure. And like I said, join us on VLab, and these are great questions, and don't hesitate asking those questions, because we have to anticipate them. I don't want to do this in a vacuum. We cannot sit in our nice little NSSL bubble and expect to do the right thing for the Weather Service. So keep us honest on all of these things.
Hey, Lance, this is Ray up at Davenport again. Do you envision parts, I hate to say facets of facets, but parts of this hitting the field in kind of a piecemeal manner as various functionalities become operationally capable? Or is it going to be more of a holistic system delivered in one shot?
No, I think there will be pieces that will start to show, like I said, mirrors. We're going to start seeing some output from mirrors that'll be visible maybe for forecasters. It may not be on AWIPS 2 right away, but our intent is to do that. But ultimately, if we're going to do this thing fully grid-based probabilistic, you look back at my slide, is the very first facet is grid-based. So it starts with that. So somewhere along the way, we're going to have to make the decision that we are going to go grid-based, probabilistic, severe convective information, and that will be the sea change at that moment. I think there are going to be some things that are going to come out early to give a hint at that, and you can start playing around with it. But at some point, there's going to have to be that major shift to grid-based severe convective information or hydrologic information and other things.
Thanks.
Yeah, I don't know if I answered that one clearly, but...
Yep. Well, and part of the thing is how it's deployed to the field goes back to the change management issue. If functionalities come in a little bit more piecemeal-wise and set us up to be capable to handle that big change, we'd be in a much better position to manage that in the local office, I think, than if it's sort of this holistic system delivered in one big package.
And that's not the intent here. The intent is not to deliver this thing in one big fell swoop. I think we have to look at hazardous weather test bed and the proving ground for forecasters to get their hands dirty on, to get some experience with it, so that by the time it does show up, it's well tested and ready to go. Trust me, I've been on the receiving side of stuff that has not been fully baked, and I refuse to go down this path unless we see the end use fully baked.
Excellent. Thanks.
And thank you, Lance, for your presentation today on facets. And thank you, everyone, for joining us. And we hope to see you next time on our next webinar in the Central Region Science Sharing Series. Thank you. Have a good